I know that you all get scared when you see proofs from scratch, but you should be able to do a proof like this from scratch. The nice thing about doing proofs for triangle congruence is you know that basically you're looking for congruent sides or congruent angles. If you have a right triangle, you can look for congruent hypotenuses or congruent legs. So this, nothing says that it's a right triangle. We're given that BD bisects angle ABC. We're also given that angle A is congruent to angle C. But I told you guys in class that if you are told that something bisects an angle, the next thing you're probably doing is showing that two angles are congruent. So I'm going to do that next. So BD bisects ABC. That's going to break it into two different congruent angles here. And trying to figure out what order I should put these letters, I see that eventually I want to prove triangle ABD is congruent to triangle CBD. So I'm going to use those same order of letters. And I'm going to write that angle ABD is congruent to angle CBD. And that is the definition of an angle bisector. Okay, and I told you once again that if you're told that a segment bisects an angle, your next step is probably that you have two congruent angles using definition of an angle bisector. Now, next thing I'm going to do is I'm going to go back and look. There is another given, and it's angle A is congruent to angle C. And this is also given. So A, I'm going to use two slashes there. C. And so now I have two congruent angles. I know that if I find another congruent angle, that doesn't help me because angle is not one of my congruence theorems. We'll learn in chapter 6 more in depth why that doesn't work. So I'm going to look for a congruent side. And when I look, I see that triangle ABD, so ABD and CBD share side BD. And I'm not sure if it's going to be reflexive or symmetric, so let me look here. In what I'm proving, B is in the second space, D is in the third, and the same thing on the second triangle, B is congruent to D. So I want to keep the order intact. BD is congruent to BD. That is reflexive property of congruence. So I have now, erase some of this stuff so I know what I have. I have shown that I have two congruent angles and I have a congruent side. And a lot of students are like, well, how do I know now whether that's AAS or ASA? So let's look at this triangle here. Let's just look at BCD. B and C are my angles, angle B, angle C, but my segment is segment BD. Segment BD does not have an endpoint of these two angles. It has an endpoint of B, but not of C. So it is not the included angle. So it is angle, side. If this said BC and segment BC, then it would be angle, side, angle. So what I'm proving is what I was told to prove. ABD is congruent to triangle CBD. I think I said that wrong. Triangle ABD is congruent to triangle CBD by angle, side. You could have put steps 2, 3, and 4 really in any order. This is the order I did it, but I would be looking for the given statement first here at the top, the proof statement here at the bottom, and then whatever order you put it. If you put BD bisects ABC and angle A is congruent to angle C both as a given, that would be correct as well. Say hi, Mr. Rowan.
Hello.
Would you like to come talk to the students in the video?
Not really.
Where did I put my thingamaboober? Oh, here it is. I'm recording! Number 31 here. I've told you guys that when you have overlapping triangles ABK to CBJ, it's best to kind of draw them out. So that's going to be ABK. And then CBJ. There. It's not perfect, but you get the point. So this is ABK to CBJ. And we're told that givens here. Let's start with AK is congruent to CJ. I'm going to actually list them all out right here. Angle BJK is congruent to BK to BKJ. That's really messy. This is BKJ. And angle A is congruent to angle C. So I'm going to mark some stuff up here. I got that AK is congruent to CJ. I got BJK is also going to be BJC. They're going to be the same thing. Is congruent to BKJ. So these are like mirror images of each other. And angle A is congruent to angle C. So actually right away I have, let's look here, I have for this one, I have an angle A, I have an angle K. So A was congruent to angle C, K was congruent to J, and segment AK was congruent to segment CJ. So you'll notice I have two angles here and I have their included side. Segment AK has endpoints of A and K. Segment CJ has endpoints of C and J. So there's actually nothing to do here. I can prove right away that these triangles are congruent by angle side angle. That was triangle ABK is congruent to triangle CBJ. All this proof was three givens that gave me angle side angle. Okay, this next proof. This really is a proof from scratch. I know that there are a total of 4 statements and 4 reasons. And I'm going to fill, actually the first thing I'm going to do, as I've told you guys, is to draw out these separate triangles. So X, W, V. And then Z, W, U. So that's not really beautiful, but X, W, V, and Z, W, U. And the first thing I'm told is that VW is congruent to UW. And I'm going to mark that. VW is congruent to UW. I'm also told that angle X is congruent to angle Z. So angle X and Z are congruent. I'm eventually going to prove that triangle XWV is congruent did I say angle? Sorry. Triangle XWV is congruent to triangle ZWU. So right away, I have an angle and I have a side. Okay, so I need to try and see what else I can find is congruent. And if I look here, I can see it here also, that this angle W is congruent to this angle W. They're both angle W. And so I have angle W is congruent to angle W, and that is reflexive property of congruence. So now I have two angles. Let's just look here. I have angle X is congruent to angle Z. I have angle W is congruent to angle W. And I have side VW is congruent to side, side VW is congruent to side UW. So the angles are X and W, but the segment is not segment XW, it's segment VW, so that's the non-included segment. So it's angle, angle, side. Two angles and a side. Number 33. We're going to prove NMK congruent to LKM. So I said NMK congruent to LKM. And I tell you guys, when you have these overlapping triangles, to go ahead and write them out. So NKM is congruent to angle LMK, and angle L is congruent to angle N. Now, even though they have these congruent markings, I'm going to go ahead and now mark them on the figures I've drawn. It helps me understand what's going on here. So NKM is congruent to LMK. Angle L is congruent to angle N. I have two angles. If I can prove LM is congruent to NK, I would have angle, side, angle. But when I look here, I don't have that, but I can see that there are two side lengths that both have the endpoints KM. So those are congruent. Now when I write it, is it KM congruent to KM? You can see that this would be flipped, but if you're still not sure, look at what you're proving. MK and KM are not in the same order. In this triangle congruence statement, M corresponds to K and K corresponds to M. So I'm going to write it as segment MK is congruent to segment KM. And that is symmetric property. Ms. Mock, you want to be in my video for a minute?
No, that's okay.
Can you give me just a minute and I'll be right there?
No problem.
We're recording. Ms. Mock doesn't want to be part of it. Symmetric property of congruence. And now I can say triangle NMK is congruent to triangle LKM by angle, angle, side. So for this last one, we have some special guests. I know that while I've been recording today, Mr. Rowan stuck his head in. He didn't want to be on my video. He didn't want to talk. And then Ms. Mock stuck her head in my classroom. She didn't want to be on my video. But we have two students who might participate. They might not. Depends how they're feeling. They're giggling. I know. You can play guess who the student is. So, shh. This is a proof from scratch. But I've told you that there's 4 steps. And I've told you that the second reason is going to be definition of midpoint. So the first thing I'm going to do is I'm going to write my given, which is that x is the midpoint of VY, segment VY, and segment WZ. Now, normally we're told just x is the midpoint of an aligned segment. And we learned, because we wrote this on the board, that if you're told that, your next step is probably going to be
two segments are congruent.
To prove two segments are congruent. Perfect. In this case, since we're given it's the midpoint of two different segments, we're going to actually be doing that kind of twice. So what I mean, and I'm going to write this step down here. If x is the midpoint of VY, that means that Vx is congruent to xy. And I'm going to mark that. So that means Vx is congruent to xy. That also means, since x is the midpoint of WZ, that
X is congruent to XZ.
It does not mean all four, what, did I write it wrong?
Isn't it ZX?
WXXZ. It's okay, so I'm just doing midpoint, okay? So it does not mean that all four are congruent to each other. That's what you want to make sure. Could all four be congruent? Yeah. It's possible, but it doesn't tell us, okay? So right now, I actually have two sets of congruent sides. So right away, when I'm trying to decide what theorems I'm going to use, I'm certainly not going to be using hypotenuse leg. I'm not going to be using angle, side, angle, or angle, angle, side, because I already have two congruent sides. So that leaves the only choices left are side, angle, side, or side, side, side. If I want to use side, 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 I'd have to prove that VW and ZY are congruent. I have no way to do that. So let me look at an angle. And hopefully you guys notice
a vertical angle.
That those two are vertical angles. Now, when looking at how to write them out in the proof, I always say look at what you're asked to prove. But the way you're asked to prove this does not have x in the middle, which it would have to be for these. So really, at this point, it doesn't matter how you write these angles are congruent. So I'm just going to write angle VXW. Now to make it somewhat make sense, I would like V to line up with Y. And I forgot my angle symbol. Don't want to do that, because if you forget your angle symbol on the test, you're losing points. Y, X, Z. And that is vertical angles congruence theorem. Sometimes I will see students write this, and then they write definition of vertical angles. It's not definition of vertical angles. It is vertical angles congruence theorem. And then I can write my final step, which is VWX is congruent. Sorry, I said VWX. I should have said triangle VWX is congruent to triangle YZX, and that's side, angle, side. So hopefully, if you've watched this whole video, I will remind you that we went there clapping, but they weren't here for the first part. We did this one from scratch. We did problem 31, which we did not do in class. We did that. We did 32. We did 33. And we've now done 34, so hopefully watching this video has helped you be a little bit more comfortable with the proof process.